So this one's a little bit trickier because even though we're going to be finding the same area, we already know what the answer is going to be. And I know you're not going to like this one. You're going to think, why are we going to do it that way? There is going to be a reason why we do it this way eventually, but right now you're just going to have to suffer through using the same exact example. But instead of integrating with respect to x, we are going to integrate with respect to y. Still finding the same exact area of the region between these two curves. We know it's going to be 1/12, but like I said, we could integrate from left to right, so in other words, integrating with respect to x. But in this case, we're going to really dig deep here. We're going to integrate from bottom to top. So let's write that down. We're going to integrate from bottom to the top. In other words, with respect to y. Just trust me, you will have to do this. You will have to know how to do this. And you can't just skirt around it and say, I'm just going to always integrate with respect to x. It doesn't work that way. So, nevertheless, when we integrate with respect to y, we can't just have y as a function of x. We need to have x as a function of y. So everything has to be in terms of y. So we take this y equals x squared, and we want to make sure we take the square root of both sides of it. In other words, we have to solve for x. Okay. So when we take the square root right there, we get plus or minus square root of y is equal to x. Well, with just a little bit of work here, you can figure out that we can't use both of those, plus or minus. We have to use only the positive. X equals the square root of y is this guy here, because when x is 1, y is 1, or when y is 1, x is 1. If we use the negative one, we get negative values for y, and that is, I'm sorry, negative values for x. That's not going to work here, because we can see all these values here are in the first quadrant, positive, positive, x and y. Okay, if you need to pause and rewind that, or if you wanted to a little bit more validity there, or confirmation that, okay, why is that? Well, if you look at the curve, y equals x squared, it looks like this. Okay, if we express y as a function of x, we're good. But if we express x as a function of y, this part of it is x equals the positive square root of y. Okay, and then over here, this is x equals negative the square root of y. It's just how it goes. Okay, and then how do we express this one here? We have y equals x cubed. Well, how do we get x by itself? We take the cube root of both sides, and that we don't have plus or minus. It's just this guy right here is x equals the cube root of y. So it's not too bad, and sometimes, well, most of the time, you'll never have to actually do too much there. It's usually a pretty easy calculation on converting to y. But and actually, these coordinates, the boundaries of our region, we've got 0, 0, and we've got 1, 1. Okay, well, the x's and the y's are exactly the same. So the integral, the area, then is still from 0 to 1. But keep in mind, the 0 to 1, we're going from the y coordinate of this point to the y coordinate of that point. In this particular example, they just happen to be the same exact thing. So the length times the width, length times the width, now it actually looks like a length. So 0 to 1, the length is this guy right here. That's why I took the time to do that in the first video. How do you find the length when you're dealing with a distance that's expressed horizontally? Well, it's the right minus the left. Okay, so we actually have the different curve now. So cube root of y minus the square root of y with respect to y. So I should say the width of this rectangle here is just a little change in y, just a dy. So normally that's gonna be the hardest part, is setting up your integrand and your limits of integration so that you can find whatever you're looking for. So that is really the hardest part. So just want to take some time just to look at that. Integrating with respect to x, we already did that. Now we're integrating with respect to y. The length of that rectangle is always going to be horizontal when you're integrating with respect to y. So keep in mind, it's the right-hand curve, the right curve minus the left curve. It's that function minus the right function minus the left function. That always gives you that length of that rectangle. And always when you integrate with respect to y, the width of the rectangle is always going to be dy. Okay, so that being said, if you want to pause the video and see if you can figure this out, I mean, we know it's 1/12. Pause the video, see if you can get there. I'm going to go ahead and continue. I would write this as y to the 1/3 minus y to the 1/2 dy. Okay, and we know that we want to just use the power rule. We add 1. So the way I think of that is y to the 1/3 plus 1, that's going to be 4/3, divided by 4/3 or multiplied by 3/4. Okay, same thing over here. Y to the 1/2 is y to the 1/2 plus 1 is 3/2, divided by 3/2 is the same as multiplying by 2/3. This is actually not that bad, because it's a 1 and a 0. We just get 3/4 minus 2/3, which is 3/4, which is 9/12, minus 2/3, which is 8/12, and you just get 1/12. There you go.